All right, so today we're going to go over the red boxes, okay? So we're skipping box number 19 and 20, but we're jumping right ahead to the red boxes, which are parallel lines cut by a transversal. So take a look at this picture. If two parallel lines are cut by a transversal, right over here, let me highlight the parallel lines in, I guess, blue, because that's what it is. This one, line A, and this one, line B, are parallel in this picture. So if two parallel lines are cut by a transversal, this is your transversal. Let me highlight it in yellow. This is the transversal. Then you know that some angles are congruent and some are supplementary. Supplementary means add to 180. Let me remind you that. Okay, add to 180 degrees. The postulate and theorem tell you the specifics. So over to the right of that, box number 21, 22, 23, 24, 25, 26, they're going to talk about which angles are congruent and which angles are supplementary, okay? So in each of these situations, line A and line B are parallel. So our two blue lines are parallel. So let's take a look at box number 21. If two parallel lines are cut by a transversal, like in our picture, then the corresponding angles are congruent. Angle 1 is congruent to angle 5. Let me highlight those in, I guess I'll do it in purple. Angle 1 and angle 5. So that's right over here. Let me get rid of all this, make it a little cleaner looking. Okay, 1 and 5. These are corresponding angles. They're corresponding because they are both in the top left position. So if you take a look at them, they both occupy the same kind of spot of the four angles that are created. Okay, so these are corresponding angles. Okay, give me one moment to fix the attendance. Okay, so once again, 1 and 5 are congruent. Do you guys have any questions? All right, I have a question for you guys. Let me see if you guys can figure out. I'm going to highlight angle number 6. So you're going to pick between these four angles, 1, 2, 3, 4. Which one is the corresponding angle to angle 6? Please say it out loud. Unmute yourself. Which one corresponds to angle 6?
2.
Yes, 2. Thank you. So 2 and 6 are corresponding angles because they are both in the top right position. So they are in the same location. They're in the same spot. They are corresponding. Okay, so now I'm going to talk about box number 22, alternate interior angle theorem. So just so you know, I might call in random people and maybe will just be prepared, okay? That's why you pay attention. So box number 22, alternate interior angle theorem. If two parallel lines are cut by a transversal, then the alternate interior angles are congruent. I'm going to draw my own picture here because I don't want to erase that. I think it's important to have those pictures. Okay, so here's my little mini picture of that. Angle 4 and angle 5 are congruent. So let me highlight those two. Angle 4 was the bottom over here, and angle 5 was the top one over here. So these two angles are congruent. And this is the alternate interior angle theorem. So let me clarify like alternate interior angles, okay? So alternate means they're on different sides of your transversal. So let me highlight your transversal. This is your transversal. Anything on one side, like those two green angles are on different sides of this bold black line, right? So that's why they are alternate. And they are interior because they're sandwiched between your parallel lines. Okay, so these are alternate interior angles. All right, let's take a look at the next one. I'm going to draw the same picture. Sorry, that's really bad parallel lines, but you get the picture. Alternate exterior angle theorem. So 1 and 7. So let me highlight 1 and 7. I'll just do it in another color again. 1 is this one over here. 7 is this one over here. So notice again that this bold black line divides the two blue angles. So they are on different sides of this bold black line. That's why they are alternate. Okay? And they are exterior because they're not between your parallel lines. Like look over at this one. These were between your parallel lines. But over here, now they're on the outside of your parallel lines. Okay? So these are alternate exterior angle theorem. They are congruent angles. They have the same measure. Do you guys have questions on these two or these, anything so far? No? Okay. Let's do same side interior angle theorem. Oops. Let me do this in black. Be consistent. Okay, so we got our bold transversal and then parallel lines as best as I can draw them. Okay, so if two parallel lines are cut by a transversal, then the same side interior angles are supplementary. So let me draw those for you. Let's do that in blue. So 3 and 5. So notice that they are on the same side, let me underline that, of our bold black line. They're both to the left bottom-ish. Okay, and they are interior because they are sandwiched between our parallel lines. So they are the same side interior angles. Okay, any questions on that one?
Can you zoom in a little bit?
Oh yes, sorry. Any other questions? Okay, let's do the same side exterior angle theorem. So over here, let me just draw right in black. Let me draw our transversal in bold and then our two parallel lines. Okay, if two parallel lines are cut by a transversal, then the same side exterior angles are supplementary. So 2 and 7. This one is 2 and this one is 7. So notice that they are on the same side. They're both kind of to the right of the bold black transversal, and they are on the exterior because they are on the outside of your parallel lines. So these are same side exterior angles. And they are supplementary, which means they add up to 180. Okay, do you guys have any questions on this one?
Miss Jade?
Yes?
I'm so sorry I was late. The Zoom link wasn't working. It just kept saying connecting and it wouldn't connect.
Oh, that's okay. I know a lot of people are having internet issues today. It's not your fault. So I'll just zoom out so that you can see the notes we've done today. Pretty much just this, just the red stuff, okay?
Okay.
And then let's do perpendicular transversal theorem. The TH dot is just a word, is a shortened way of saying theorem. It just didn't fit. If a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other. So let me draw this out for you. Let's have our two parallel lines. Okay, and then let's have our transversal. I'm going to draw it in bold. It's not very nice looking, but just know that I drew two parallel lines and a transversal. So what this is saying is if your bold transversal line is perpendicular to one of your parallel lines, then it must be perpendicular to the other parallel line as well. Okay? So if it's perpendicular to one of them, it's perpendicular to the other. Do you guys have questions on any of any of the stuff that we did today here? I'm gonna copy the picture from the first one. Okay, so no questions, then I'm gonna start asking you guys some questions. So I'm gonna erase this a little bit over here. And I'm going to highlight two angles, and then I'm gonna call on people to see if they know if it's same side or alternate, interior or exterior. So let me write out your options. Same, oh gosh, such messy handwriting. Let me do this again. Same side versus alternate. So here's one set of answers, and the other set that you gotta choose from is interior versus exterior. Okay, so I'm going to call on people and you're gonna tell me if it's same side or alternate, interior or exterior, based on the two that I chose. But I'm also gonna not record this, okay, so you don't have to feel weird about it being on the internet.